A warm welcome to you viewers, especially the students. I'll be continuing with the chapter Reflection of Light, and today's topic is Refraction of Light. So what is refraction of light? Okay, now before we go to that, first, okay, now light, okay, it travels with speed. Okay, it travels with some speed, and you know that the speed of light in vacuum, like, is equal to 3 into 10 to the power 8 meter per second. Means in 1 second it can travel up to 3 into 10 to the power 8 meter. Okay, which is the fastest. Okay, so what happens is that, okay, now for example, okay, the sun, okay, it emits light, okay, being a source of light. So what happens to the speed of light, okay, when it strikes another medium? Okay, it's traveling through vacuum, the speed is this, okay, and then suppose, okay, let's say it travels through water. Now what will happen to the speed of light? Will it remain the same as 3 to 10 to the power 8 per meter per second? Now actually, now it is found that the speed of light in water is quite less, okay, because you know that for vacuum it is the highest, okay, and also in air, okay, the speed of light in air is comparatively close to that of vacuum. Okay, so for solving numerical problems, sometimes we take the speed of light in air as 3 to 10 to the power 8 meter per second. Okay, so now it is observed that, again, that the speed of light in different media also varies. Okay, means for water the speed of light will have another value, for glass also another value. Okay, so it is because of this change of speed of light which results in refraction of light. Okay, which results in refraction of light. Now for example, okay, two media, okay, air and water. Air and water. Okay, then light is traveling through air in its path, okay, usual path. Now what happens as soon as, okay, what happens to the speed of light, okay, when it strikes the surface of separation between air and water? Okay, so what happens to this ray of light? Okay, now before this, okay, let's take first for a case when the ray of light, okay, it's traveling normally. Okay, traveling normally. Now as it strikes the surface of separation, okay, now no bending will take place. Okay, in other words, okay, it will travel in its usual path, okay, in its usual path, but then what happens is that the speed, okay, it will be less, okay, because air is comparatively close to that of the speed of light in vacuum, and here it is quite less, so obviously the speed will change as it goes from air to water. And not only that, okay, the speed as well as the wavelength, it will change, but the frequency remains the same. Okay, so speed and wavelength, it changes whenever light travels from one media to another media. So a medium through which light passes, okay, it is called an optical medium. We have done this, okay, in the beginning of the class. Okay, and we have classified also the transparent and translucent and opaque objects. Okay, so here we'll be basically dealing with transparent, okay, transparent medium. Okay, what happens when light travels from one transparent medium to another transparent medium, like for example from air to glass, water to glass. Okay, now this is not for opaque bodies, okay, it's basically for transparent medium. Okay. So first, okay, we know that one of the characteristics, okay, of light is that the speed of light in vacuum, okay, is 3 × 10⁸ meter per second, which is so fast. And sometimes, okay, because the speed of light in air is comparatively close to this one, sometimes we take it to be 3 × 10⁸ meter per second. Okay, unless mentioned, then we take that value, but if not, we take this as well. So, and also the speed of light, okay, in different media, it is different. Okay, means that speed of light in water, okay, it will be different. Speed of light in glass also, it will be different. And it is because of the speed of light, okay, of this change in speed of light in different media, which results in the phenomenon called refraction of light. Okay, it is because of the change in speed of light in different media which causes this. Okay, so let's illustrate this, okay, with the help of an example. Okay. We have taken two transparent mediums, say air and glass. Okay, and then this is the area or a surface of separation between air and glass. Now, we'll take only one particular one ray of light. So it will travel in its usual path, okay, in air. And then what happens as it strikes this surface of separation between air and glass? Okay, that is the question. Will it continue going along its path, or will there be a change in its path? Okay. So with regards to that, okay, first we will consider the case where light travels perpendicular to the surface of separation. Okay. Now when light travels normally, okay, like in the direction which is normal to the surface of separation, now no change in direction will take place. Okay? No change in the direction of the ray of this ray of light will take place. Okay? So, however, since you know that speed of light in air is different and speed of light in to speed of light of light in glass, so when light travels here, the speed of light will be more. But as soon as it reaches here, okay, it slows down and then it travels, okay, with a lower speed compared to air. Okay, so the speed will be quite low compared to the previous. Okay, and not only that, the wavelength also will change. Okay, from here, the wavelength will vary as it travels from air to glass. Okay, so it is this surface of separation. Okay, so next, okay, let's consider a case where it travels obliquely. Okay, where it travels obliquely. Okay, obliquely means when it travels at some angle. Okay, not perpendicular. Okay, now it's traveling in its usual path, and then what happens as it strikes this surface of separation? Okay, it is found that the ray of light will not continue in its usual path, but rather it will change. It will bend. Okay, it will bend. This ray of light will bend. Okay, so this phenomenon where the ray of light, it bends, as it travels from one medium to another transparent medium. This is called refraction of light. Then now first let's deal first with with terms optically rarer medium, and we have optically denser medium. Optically rarer medium. There are two ways. One is it is in terms of refractive index, and another it is in terms of speed of light. So now, since you already know what is the concept of speed of light, so we'll try to understand the definition of these two terms with respect to speed of light. Now, this is when speed of light is more. Now, and then this is when speed of light is less. Now, how can you say that? Now let's take for an example first. Like water and glass. Now suppose the speed of light here, it is 2.25 into 10 to the power 7. And this one is 2 into 10 to the power something, say 7. Let's take an example. Now if you compare the speed of light in these two media, you will find that the speed of light in water, it is bigger than that of glass. So this will be called what? An optically rarer medium. And this will be called what? An optically denser medium. So we call them only when after comparing between the two medium. Which one is rarer and which one is denser? The one where the speed of light is more is rarer, and the one which is less is an optically denser medium. And remember that optical density has nothing to do with mass density. Mass density is different from optical density. Now we'll talk first about the two medium. Optically rarer medium and optically denser medium. So this is a medium in which speed of light is more, whereas this is in which the speed of light is less. So for example, like water and glass. The speed of light in water, it is 2.25 into 10 to the power 8 meter per second, but here it is 2. And then you compare the speed of light between these two, you find that the speed of light in water is quite bigger compared to that of glass. So after comparing, then you can conclude now which of these two is rarer and which is denser. So this is rarer, optically rarer medium, and this is optically denser medium. Now the detail about this optically rarer and optically denser medium now will be further explained in terms of refractive index. As for now, since you're quite familiar with speed of light, so we'll first definition first to explain in terms of speed of light. Now let's take the same example. Water and glass. So water and then glass. Let's take air. Let's take air. Air, glass, and then air. You know that the speed of light in air is much larger than that of glass. Okay, speed of light in glass. Now, so this one is optically rarer medium and this one is optically denser medium. Now, you know that when light travels, okay, perpendicularly, okay, what happens when it strikes this surface of separation? It will continue to travel in its usual path, okay, but the speed of light will vary. However, okay, when it is traveling obliquely, okay, means at some angle. Now what happens is that due to the phenomenon of refraction of light, it will bend, okay, because why? I told you that refraction of light occurs because there is a difference of speed between these two media, okay, so that is why refraction takes place. And this is the point at which the incident ray strikes, okay. So what happens is that it will be refracted, okay, it will be refracted means it will bend. So the question is, will it bend towards the normal, okay, this perpendicular line, okay, drawn through this point where it strikes, okay, this is called point of incidence, this is normal. Then will it bend towards or away from the normal? Okay, actually when it travels from rarer to denser, okay, it will bend towards, okay, it will bend towards the normal, okay. So this, okay, is the incident ray, okay, which is traveling through the medium, okay, the first medium. This is called the incident ray. The point where it strikes the surface of separation, this is called the point of incidence. And then this is called the refracted ray, okay. And then again this ray, refracted ray, now will behave as the incident ray, okay. Now incident ray, why? Because now light is traveling from glass to air, okay, again two media. Now this is what? Glass is denser, but then air, it is a rarer, optically rarer medium. Previously we have when light travels from rarer to denser, it bends towards the normal, right? So now, okay, this is the point of incidence, okay, denoted by O prime. Then we'll draw a normal through this point of incidence, another normal. Let's take this as M prime and this one as N prime. However, when it travels from denser to rarer, the ray of light, it will bend away from the normal. Okay, you see here the angle here. Okay, it will be quite far away from the normal. So always remember, from rarer to denser towards, from denser to rarer, it will be away from the normal. Okay, then this angle here, okay, which first this ray, okay, is called the emergent ray. It's called the emergent ray. And then this angle, which the incident ray makes with the normal M prime, this is called the angle of incidence, okay, denoted by angle I, okay. And then this angle where the refracted ray makes with the normal M prime, this is normal and n prime. So they are alternate interior angles, and hence this angle will be equal to angle. Okay. So remember that from rarer to denser, bend towards, and denser to rarer, bend away from the normal.